This section 3.5 is on polynomial division. There's pretty much one thing that's required when we talk about polynomial division, and it's pretty much by name. It's long division of polynomials. Some of you may be familiar with this section in its entirety. There is a special kind of polynomial division called synthetic division. You can't use it all the time, but when you can use it, it's much quicker. And I have a problem or two on that at the end as well, because setting that synthetic division up is not really the easiest thing, but once you get rolling with it, it's not too bad. The polynomial division, it's pretty much what it sounds like when it comes to polynomials. Sometimes you want to divide them. We'll see why in the next section. But the way we can write it is if f and g are both polynomials, then when f is divided by g, so f of x divided by g of x, it can take on two forms. One form, it looks like f of x divided by g of x equals q of x plus r of x over g of x. Q of x is called the quotient, and r of x is called the remainder. Q for quotient, r for remainder. F of x and g of x in general terms have names, divisor and dividend, but you don't need to remember that. Quotient and remainder are what you need to remember. Now an equivalent form to this is if you multiply this equation through by g of x. If you multiply everything by g of x, then the g of x goes way over here and you're left with f of x. If you multiply g of x to the q of x, you get q of x times g of x. And if you multiply this by g of x, the denominator goes away. Right, these are the same form, same formula. Sometimes when it comes to dividing polynomials, the first way is better for what you want to do. Sometimes the second way is better. All right, but we'll talk about polynomial division. One thing that is important that I have highlighted here, and I would definitely write down, to know when you are done with polynomial division is when the degree of the remainder is smaller than the degree of g of x. Okay, so these q of x and r of x are going to be polynomials. When you are done, it's indicated by the degree of r of x being smaller, and we'll see how we can tell what that's going to be. But this first example I have here is just totally walking through the individual steps, and then I'll use those steps when we go through the rest. All right, so one way you might be asked on the homework is to determine the quotient and remainder when x squared minus 7x minus 4 is divided by x minus 8. So if you remember the old way you learned hopefully how to divide numbers is when you did numbers divided by each other by hand, you had this almost radical bar but not the extra thing, and you put some stuff that you were dividing by out front and the stuff that was being divided inside. All right, same thing for polynomial division. The stuff that we are dividing, which is the x squared minus 7x minus 4, is going inside, and the stuff we are dividing by goes on the outside. Okay, so I'm going to go ahead and set this up. When we want to divide these, we start by putting the thing we are going to divide, x squared minus 7x minus 4, on the inside, and the thing we're dividing by on the outside, x minus 8. All right, so that's the setup. Now the way you go about doing polynomial division, if you remember doing this with numbers, I'll write down a really very brief example, but if you did 4 divided into 17, you would start by asking the question, how many times does 4 go into 17? It goes 4 times. Then we multiply the 4 times 4 to get 16, subtract it, and we're left with 1. And this was the remainder, and this up top is the quotient. So to mimic this for polynomial division, we kind of do the same thing, but only with the leading terms. Meaning, the first thing that goes up here is what we get when we divide x squared, the leading term inside, divided by x. Okay, when you divide the leading terms, and you can very much do this by hand, just do it on the side. You kind of want to keep your work clean because it's easy to make a mistake. It's a little messy. We divide our leading terms. We do x squared divided by x, which simplifies to x, and that's what starts by going on top. All right, so that's like our 4 over here. Now we figured out how many times x goes into x squared. We put it up top. Now we multiply the number through, or this time the letter. So we distribute the x, what we put up there, through the x squared minus 8, and we get x squared minus 8x. Now once you multiply it over here, 4 times 4 is 16, we subtract. Same thing over here, you subtract. But you got to be careful with this when it comes to division. When you subtract, when you put the minus sign, you got to make sure you're subtracting the whole thing. So you can either put this in parentheses, or what some people like to do is switch the sign on everything, which is totally fine. So what I mean by that is you can have a minus x squared and a plus 8x. All right, but I'm going to go ahead to avoid confusion. If you look at these notes, I'm going to not write in both types. Yeah, but I'll do it the other way, the next step, so you can see it. All right, so what we do, we subtract now, as long as you have everything set up well, which I'll talk about the problems we could run into in the next problem. Everything should be in line, meaning x squared should be on top of x squared, x should be on top of x. We don't have anything else over here. One thing that's very important, if you did this right, the leading term should cancel, and it does. X squared minus x squared goes away. And then here we have negative 7x minus negative 8x. The minus negative gives us a plus 8. That is just x. And this negative 4 that we didn't touch is still there. We just bring it straight down. All right, now the question is, are we done? Do we have to keep going? We do have to keep going because this right down here, it would be the remainder, just like the remainders on the bottom over here. But the degree here is 1. It is not smaller than the degree here. So we got to do one more step. And we do the same thing as before. We divide the leading terms. Now we divide x is our leading term underneath by the x. And we get 1. X over x is 1. So we got a positive. Make sure you put a plus 1 there. But then we just do the same thing as last time. What we put up here, we distribute to the x minus 8. And so 1 times x is x. 1 times negative 8 is negative 8. And if we switch the signs to do the subtraction, we get minus and we get a plus. So whichever one you like. You can put the minus sign out front of a parentheses. You can switch the signs. Doesn't matter. But once again, to know you're on the right track, the leading term should cancel. X minus x does cancel. And we got negative 4 plus 8 is 4. And at this step, we are definitely done because the degree here is 0. The degree of a number is 0. Hopefully you remember that. It's just smaller than the degree of 1, which is the degree of the thing we're dividing by. So that's how we know we're done. The degree down here is smaller than the degree over here. And just to formally answer the question, now that we are done, the quotient is the thing on top. Q of x equals x plus 1. And R of x, the remainder, is the thing down here. Now, both of these can be just numbers. Both of these can have x's in them. It can be mixed and matched. It just depends. But that is the idea behind polynomial division. And really, it just takes practice. I'll go ahead. I got a couple more here. One thing I want to point out about this first one, and I know the numbers look big. The numbers are chosen to work out, make everything work out pretty nicely. Don't be afraid of them. You know, if you get big numbers, it's not going to be a big deal. All right, so same thing here. Determine the quotient and remainder when the following polynomials are divided. So we'll do that, and then I'll write it in the two forms, because the homework typically asks you to write in one or the other. Okay. So we got 25x cubed minus 35x squared plus 28x minus 35. One thing I'll point out here is there's no missing powers of x. It goes 3 to 2 to 1 and then 0. So I'm going to fill it inside like that. And then the outside, the thing we're dividing by, what you'll notice here is we're missing an x. We have x squared, we don't have x as the first power, and then to 6. What you want to do is really use 5x squared plus 0x plus 6. Fill in that missing power. Because what happens if you don't fill in the missing power and you kind of look too quickly is the powers won't line up like this, and then you might end up subtracting and adding things that aren't like terms, right? We can add x squared with x squared. We cannot add x squared with x. And so I'm going to put that out here. 5x squared plus 0x plus 6. Right. But once you've got it set up, same thing as before. It doesn't matter what the numbers are. Start by dividing the leading terms. 25x cubed over 5x squared. 25 over 5 is 5. X cubed over x squared is x. That's what we'll put up top. And then we distribute the 5x through. 5x times 5x squared is 25x cubed. 5x times 0x, once again, I will write this in. 5 times 0 is certainly 0, but x times x is x squared. You'll see what happens here is the x squared is now right below it. Works out pretty nicely. And 5x times 6 is 30x. All right, now it's up to you what you do. Once again, you can write the minus sign and then write the parentheses, or you can switch the signs. I'm going to just switch the signs on everything. Most people like this more. And if we did it right, if we multiplied by the right thing, they can't, leading terms should cancel out, and they do. Negative 35x squared plus or minus 0x squared minus 0x squared doesn't change it. We still got negative 35x squared. And then 28x minus 30x is negative 2x. And we bring the negative 35 straight down. That did not get touched. Okay, let's ask ourselves, are we done here? Well, is the degree of our remainder down here, which is 2, less than the degree of the remainder here, which is 2? And the answer is no, they're the same. So we got to do it again. And we got to divide our leading terms here. We got to do negative 35x squared divided by 5x squared. The x squareds cancel. Negative 35 over 5 is negative 7. When you have a negative number there, it's just a minus. Yeah, minus 7. But we distribute again. Negative 7 times 5x squared is negative 35x squared. Negative 7 times 0x is 0x. Since it's 0, you don't really have to put plus or minus in particular, just either one. And then negative 7 times 6 is negative 42. Go ahead and switch our signs. Minus, they're all minuses, we make them all pluses. And if we did it right, once again, we should get the leading terms to cancel. And they do. Negative 35x squared plus 35x squared cancels out. Negative 2x plus 0x is negative 2x. And negative 35 plus 42 is positive 7. Right, and we are done now because the remainder is degree 1, which is less than the remainder, or less than the degree up here, which is 2. So the degree down here is smaller than the degree up there. So that tells us we are done. And our quotient is what's on top. Q of x equals 5x minus 7. R of x equals negative 2x plus 7. Now to write it the two different ways depending on the homework. F of x over g of x. I won't rewrite the formula, I'll just scroll up to remind you. F of x over g of x equals q of x plus r of x over g of x. So we write our quotient, 5x minus 7, plus r of x, which is negative 2x plus 7, over the thing we were dividing by, which is 5x squared plus 6. Now, you don't need to write the 0 in anymore. That's only, to make it easier to multiply. The other way, f of x, once again, I'll just scroll up. So to remind you, it's q of x times g of x plus r of x. We got q of x is 5x minus 7 times g of x equals the thing we're dividing by, 5x squared plus 6, plus r of x, which is negative 2x plus 7. Now this certainly doesn't have to be in parentheses, but these two need to be in parentheses because they're multiplied. All right, so just depending on the question is how you would write it. You're almost always writing one of these two right sides, but look at the question carefully. All right, really the only way to check that, see that your answer is right, is if you did multiply this out and then add like terms, do you get the f of x back? But I'll let you enjoy the fun of that on your own if you'd like to try. All right, so the last one here for direct polynomial division is similar to the one above, except we're missing a term in the thing that's being divided, the thing in the inside. All right, so what's going to go inside? We got x squared plus 4x, or sorry, x cubed plus 4x squared plus 71. We have no x term. Just like last time, you want to write in a 0x. If you had the missing x squared part, you would write in 0x squared. It's very helpful, highly recommended. And so we got x2 out front, so we're dividing by, and on the inside we got x cubed plus 4x squared plus 0x plus 71. And we start the same way. Nothing is ever going to change about the procedure of polynomial division. We start by dividing the leading terms. X squared, or x cubed over x, which is x squared. It's the first thing that goes on top. We distribute through. X squared times x is x cubed. X squared times 2 is 2x squared. And then switch the signs or subtract, whatever you want to do. I'll subtract. The x cubes do cancel out. And we got 4x squared minus 2x squared is 2x squared. Both of these were not used, but make sure you bring them both down. Don't neglect that 0x that you threw in there. And the question now, are we done? Well, the degree up here is not smaller than the degree down here. We are not done. We got to divide. Again, 2x squared over x. 2 stays. X squared over x is x. We have a plus 2x up top. We distribute it through. And we got 2x times x is 2x squared. And 2x times 2 is 4x. Now switch the signs. The 2x squareds cancel out, which is what we wanted. 0x minus 4x is negative 4x. And the 71 we got to bring on down again. That did not get touched. Once again, we ask, are we done? And the answer again is no. The degree down here equals the degree up here. They're both 1. We got to do it one more time. Excuse me. So we divide our leading terms. Negative 4x divided by x. The x's cancel and we're just left with negative 4. That's what goes on top. Distribute it. The negative 4 through. Negative 4 times x is negative 4x. Negative 4 times 2 is negative 8. Switch our signs one last time. They both become plus. And the negative 4x plus 4x cancels out. 71 plus 8 is 79. Okay, we got our q of x, our quotient is x squared plus 2x minus 4. And our r of x, our remainder, is 79. Okay, you can go ahead and plug it in either form. It doesn't matter which one you do, it just depends on the problem which one you do. But for me, in general, one of the two is going to be fine. Just understand what the homework's saying. Right, so f of x over g of x equals q of x plus r of x, which is just 79, over the thing we're dividing by, x plus 2. Or f of x equals q of x, x squared plus 2x minus 4, times g of x, which is x plus 2, plus r of x, which is 79. And so if the directions just say figure out the quotient and remainder, you're done there. If the directions want you to use one of these two forms, make sure you use the correct one. As far as polynomial division goes, the only way it really gets complicated once you practice it enough, you don't want to forget about adding in the missing portion so everything lines up correctly. The last thing in this section is synthetic division. And the thing about the synthetic division, it's pretty challenging to just describe. So I'll go ahead as I work the problem out to do it. You will see a couple homework problems on it. One of them really sets the whole thing up for you to really guide it along. But the reason why synthetic division is ultimately optional is you won't always be able to do it. It does tend to be common enough to use that it's worth learning, but it's totally up to you. In the special case of dividing polynomials, f of x and g of x, I don't know why I didn't highlight this. This is important. Where g of x equals x minus c. So g of x is x minus a number. It could be plus a number. That just means c is negative. You can do synthetic division. It's very literal though. It cannot be 2x minus a number. It cannot be 2x plus a number. It cannot be x squared minus a number. It has to be just x minus the number. All right, so the way we set this up, I'll describe it as we work through this first problem. We want to do synthetic division and divide x cubed plus 2x squared minus 13x minus 3 by x minus 3. Well, the first thing to do is realize we can do it here because it's x plus or minus a number. And the number here that we are subtracting is 3. So c equals 3. What we do, what at least I do to set up, is I put my c in the upper left-hand corner. And once again, this is the way I set up. Is pretty much the most common way. All right, what we do next, you start with all the coefficients of your polynomial, the leading one. We start with a 1. Then we go over to the next number, which is 2. Then the next one, which is negative 13. And the last one, which is negative 3. We write them in order, descending order of powers. We add x cubed, then x squared, then x, then the number. And we'll see, just like with regular long division, if you are missing a power like the one down here, you will have to make sure you add in the 0. Right. Then leave some space here and make a bar. What's going to end up happening is we're going to put some stuff down in between and down here, fill out some numbers. And what goes along with these numbers down here, all the powers get decreased by 1. So the number that's going to be below here is x squared's coefficient. The number below here is x coefficient. The number below here is just the number. And what goes below the number is the remainder. So the powers go down by 1 everywhere, and the number becomes the remainder. Right, so once you're here, you're totally set up for synthetic division. Now it's a matter of doing it. You start by bringing the first number straight down. You only do this with the first one. We bring that number straight down. And then we take this number and we multiply it with c. And then whatever they multiply goes right here. So 1 times 3 is 3. All right, once you fill that number here, what you do with these two numbers is you add. So this is what kind of makes it confusing, I think, with polynomial division is polynomial division. You subtract the stuff, and synthetic division, you add the stuff. Okay, so 2 plus 3 is 5. But we just continue doing this the rest of the way. We take our number down here, we multiply it by c. 5 times 3 is 15. We add negative 13 plus 15, and that is 2. We still have another column, so one more thing to do. We multiply 2 times c. 2 times 3 is 6. And negative 3 plus 6 is 3. So once you're all filled out down here, you can directly see the remainder. It's just the number 3. And the quotient, especially if you wrote this stuff down here, it tells you exactly what it is. It's 1x squared plus 5x plus 2. Always linked by pluses. 1x squared plus 5x plus 2. Typically, we wouldn't write that one in there. So 5x squared plus 5x plus 2. Right, but synthetic division, the process is much, much quicker. And it's worth learning. But as I reiterated, it's up to you if you want to use it on the test. All right, so we'll do one more here. I wanted to make sure we did one with what's going to happen here. Use synthetic division to divide x cubed plus 10x squared plus 19 by x minus 2. What I want to point out here is this is something we can do because it's x plus or minus a number, but the c here is negative 2. This is because x minus c, we take the opposite sign. X plus 2 is x minus negative 2. And we'll fill out the rest like we did last time. We start with our x cubed because that's the biggest power, then our x squared, then our x, then our number. All right, so those coefficients on x cubed is 1. The coefficient on x squared is 10. There is no x here, which means the coefficient is 0, and the number is 19. We leave some space like we did last time. And I just like filling this out to remind myself the powers are always going to be 1 less. So it's going from x cubed to x squared to x to a number, and number becomes the remainder. Right, we start by bringing the first number straight down. We get a 1. We multiply the 1 by our c, which is negative 2, to get negative 2. We add together. 10 plus negative 2 is 8. Then again, multiply the number down here times c. 8 times negative 2 is 16. We add them in our column. 0 plus 16 is 16. And then last, do it once more. 16 times c, 16 times negative 2 is negative 32. And 19 minus 32. 19 plus negative 32 is negative 11. So our quotient, we got 1x squared plus 8x plus 16, x squared plus 8x plus 16. And we have our remainder, which is negative 11. Now you will see at times in the next section what's going to be heavy on using this polynomial division, syntactic division. When we can use syntactic division, I'm going to use it because it's much quicker. But there are some times when we cannot use syntactic division. So you absolutely have to learn polynomial division, and it's very helpful to learn syntactic division as well.